It is my pleasure to welcome Ryan Carle, who is our speaker tonight. Ryan is the science director for Oikonos Ecosystem Knowledge, which is an international conservation science nonprofit. Ryan currently conducts phalarope research at Mono Lake and coordinates with phalarope research partners around the Western Hemisphere, and that does include SFBBO. Ryan has worked for over 10 years on conservation and research of seabirds and shorebirds in California, as well as in Chile. But his favorite place to work is Mono Lake, where he was born and raised. So Ryan, thank you so much for joining us tonight. I'm really excited to hear your talk.
Thank you, Serena. And yeah, I'd like to thank SFBBO for hosting this. It's really lovely to work with our partner organizations and share our stories together. And I'm based just over the hill in Santa Cruz, and they're over there in the Bay Area. So it's our sort of local connection here, even though I'll be talking a lot about the desert and the South America and things. So yeah, the title here is Mono Lake to Mar Chiquita, from the Northern Hemisphere to the Southern Hemisphere, the future for phalaropes and saline lakes. And I hope that that title kind of makes sense by the end of this talk. This picture here is a nice image of phalaropes at Mono Lake, which I'll be talking about tonight, and among other places. I want to introduce you to Oikonos, the org that I work for. First, we're a conservation science nonprofit similar to SFBBO, and in our work, we have a mission to use science and art and design and collaborate with communities to do ecosystem conservation. And sort of just because of the interests of the folks that work for Oikonos, we've primarily worked on seabirds and islands around the Pacific Ocean, and the expansion to saline lakes and phalaropes was a little bit of a departure, even though they're water birds, from our normal jam, so to speak. And we work in Chile, Hawaii, and California primarily. And we work a lot with local communities in Chile, especially on islands. Like this is the Juan Fernandez Islands in this beautiful photo, where folks are living out there in very isolated areas with really threatened ecosystems, and they're stewarding them. So just to give you a sense of where we work, these red arrows show the places where we have projects, and much of the emphasis is on seabirds. The species are pointing to the areas where we have projects. Maybe if you're in the Bay Area, you're familiar with Año Nuevo, where we work on rhinoceros auklets at Año Nuevo Island. Won't be talking about that tonight, but it's a fun project. And then some of the other places that we work are on shorebirds and saline lakes, including Mono Lake, and also our Chilean program has an emphasis on the Altiplano Andes region, where the saline lakes are, and down there. So that's a little bit about Oikonos, and I'd like to start by introducing what the heck is a saline lake. And saline lakes are weird. They're salty, hence the name. They're alkaline, which means they have a really high pH. It's kind of like baking soda. And they're called terminal lakes, which means that the water goes in and it doesn't have anywhere to get out except through evaporation. So you think of like Lake Tahoe, it's got water going in, it's got water going out. That keeps it fresh. But these lakes become salty because they don't have a place for the water to go. And this means if the lake is old, it's really salty, and fish can't live in it. It's too salty for that. So it has these specialized invertebrates. Maybe you've heard of brine shrimp and brine flies that provide tons of food for birds. And that's one reason that they're really important lakes, among others. So why should we care about them? They're sort of an undervalued ecosystem, and they have been historically like not cared about very much, and that's one reason that we have problems today. But they're critical migratory bird habitat. This picture is of phalaropes at Mono Lake using the habitat. An interesting piece of the story is that they are currently, as we speak, experiencing the devastating impacts of climate change, and this is a warning story for the future. And if we can solve this story, then we have some hope that we can solve other ones. As Serena nicely pointed out, there's a deep connection of history with indigenous cultures at these lakes in each of these places I'm talking about. And if we lose these lakes, we're losing thousands of years of human cultural connection to them. and they support our contemporary economies. You wouldn't really want to visit Mono Lake if it was a dust bowl. And we also have these unique brine shrimp fisheries at many of these lakes that support local economies. And just to drive that point home, this is Owens Lake in Eastern California that dried up in the 1800s and had terrible, terrible dust storms that really caused horrible problems for the local people. It doesn't look like this anymore. They've done a lot of great work to mitigate these dust storms, but when this is what could happen at Great Salt Lake if things go the wrong direction. So some of the lakes I'll be talking about are on this map here. They're mostly located in the Great Basin Desert in Western North America. I have the indigenous names next to the settler names there. All the indigenous names have pa in them, which is my understanding is that means water in the Numu Paiute languages. So yeah, just to orient yourself to where we're talking about, Eastern California on the other edge is Great Salt Lake in the Western Great Basin. So Mono Lake, or Kutsapa'a as it's known, is like I said, next to the Sierra Nevada in Eastern California. It's a really beautiful lake, which is one reason it's gotten more attention than other saline lakes. Here's an aerial image of it showing the snow that runs down the mountains and just lands in this basin where it doesn't have an outlet to the ocean. That makes it 2.5 times saltier than the ocean, and it doesn't have any fish in it. So yeah, you float really well. It's really salty, and it's full of food for birds, like I mentioned. Because there's no fish in it, those invertebrates that I mentioned, they're not being eaten by fish, so the birds are the main things eating them. And these are those invertebrates I'm talking about, the Artemia brine shrimp, which is itty bitty. They're not like your cocktail shrimp. They're really tiny. And then the alkali fly, which is seen here scuba diving. They form an air bubble around themselves and can walk underwater on the rocks where they're going to lay their eggs and have their pupa and larvae develop. And tasty, tasty invertebrates for the birds. So there's so many of these invertebrates at the lakes, at the saline lakes, that a gull can just run along the shore and with its mouth open and just vacuum them up. So it's kind of an all-you-can-eat buffet. And that is really important to have this reliable, excellent food source in the middle of the desert. And it's especially important for several species. Saline lakes tend to be sort of low diversity of invertebrates, low diversity of birds, relatively. They're really important, but for a small number of species, they're super abundant. So I say low diversity, which is we think of as bad, but it's not. And then we have abundance of a really big abundance of a smaller number of species that really, really rely on the lakes. So 70% of the world population can be at those lakes I just showed you of Wilson's phalaropes in the world at one time. And 10% of the red-necked phalaropes in the world can be at those lakes and at one time. Eared grebes is similarly high. Almost the entire population can be at the lakes at one time. You get the point. California gulls and avocets are similar. And I just want to show this picture again because I like it, and it really shows, wow, there's a lot of phalaropes using the lake in this picture, and that kind of conveys the importance of it. So I'm going to zoom through the story of Mono Lake from its policy history. Maybe some of you are familiar with this, living in California, many of us. So Mono Lake Los Angeles was diverting the water from the freshwater input creeks that were going into it in the 40s and taking that fresh water down to LA, which really promoted the growth of LA. The Mono Lake Committee and their partners, they were battling for many decades to find a solution to not have Mono Lake die, basically, and also not have Los Angeles die and share the water. In 1994, this bore fruit, and the California Supreme Court shared the water between LA and Mono Lake and set a mandated level for Mono Lake to come back to. And this worked out for everybody because Los Angeles got really good at conserving water, and the city is still doing just fine, which is a great success story, except that the lake hasn't come up to the level that was set. So it's a great success, and it also is nuanced in the sense that climate change has made it not come up to where we want it to be yet. So that's Mono Lake, and I'm going to tell you something about my connection to Mono Lake now. This is me as a kid in the Bridgeport 4th of July parade, just as an alkali fly. So I come by my interest in saline lakes. Honestly, my parents are the folks there in this picture too. That's my mom and dad, the rangers. My dad dressed as a 2-foot tower, and my brother super happy about being dressed as a brine shrimp there. So yeah, I grew up in Mono Lake, and my family has cared about it and connected with it for a long time. And 25 years-ish later, I'm really happy to be working there and get to go back home. And I've been living in Santa Cruz a long time, so get to go back and work at my home place that I care a lot about. So why phalaropes? For me, it's that I get to go to Mono Lake, but quickly this story became about a lot more than that. Phalaropes are really special in that they connect saline lakes across the entire hemisphere, and saline lakes all have very similar problems, similar wonderful things about them, and similar issues. And Wilson's phalaropes particularly are going through the entire Western Hemisphere and hitting up all these lakes. The same individual bird might go to all of these 4 sites in a year that I'm highlighting here. And that is quite amazing. And really, they are connecting this whole network. And then what I'll be really underscoring in this talk is that saline lakes are really threatened. Here's a good example. Lake Abert I showed you in southeastern Oregon on that map has dried up. And in 2015, it was dry. It briefly was wet again, and then it dried up again in 2021, 2022. So we lost one of the big lakes for the time being that the phalaropes go to. I'll talk a lot more about that topic, but first, I want to talk some more about phalaropes. So here's a little interactive attempt at some interactiveness. Talk to somebody next to you if they're there, or talk to yourself in your head. But how much do you know about phalaropes? Try to see if you know which one of these is a Wilson's and which one is a red-necked phalarope. So I'll give you a second to think about that. Okay, maybe you thought about it. So we got the Wilson's phalarope on the left, the red-necked phalarope on the right. They both have red necks, confusingly, but I'll talk a little bit more about the differences. But you can see the plumage differences here. They call the Wilson's phalarope the tricolored phalarope too, because it's got that nice like 3 lines of color on its neck. I want to show why people connect with phalaropes. Can you all see this video that's primed up? Okay, here we go. So that's pretty cool. And I think that's why I see phalaropes as a really great connector of saline lakes too, is that people can connect to phalaropes, and it gives us a very tangible piece of the sort of the soul of saline lakes to see that out there from a canoe or in a video. So the Wilson's phalarope, I'm going to give you a little bit of background info about these species. We're looking at the range map here on the right, with the red being the breeding range. So they're breeding up in central North America in freshwater wetlands, and then they're going to stage, so to speak, at the saline lakes. When staging means that they're going to eat a lot of those shrimp and flies, mainly the flies, they're going to double their body weight and regrow all their feathers and prepare to leave on a nonstop journey down to Peru is where, or Ecuador actually is where they're going to, both Peru and Ecuador, they're going to land, and then they're going to journey down to the Andes in Argentina from there. So that's about over a 3,000-mile flight straight from our saline lakes down to the coast of Ecuador. They'll have lost all that fat that they put on by the time they get there. And I've already maybe imposed this on you, but I want you to remember this species is the best indicator of saline lakes as a network. That's what I want you to take away from this talk, knowing about Wilson's Phalaropes. We don't know a lot about their population trends. We have a very rough estimate of their world population of 1.5 million birds from the 80s. That's very rough. And we don't know very much about the status, especially of their South American habitat, how it's doing, or exactly where it is and which places are most important. Red-necked Phalaropes are other species. They're breeding up in the Arctic, way up in the tundra. They're migrating through the Great Basin and stopping at our saline lakes. They're also stopping along the coast. So if you're on the coast in California, you'll see them on the ocean. And they are going to go down to South America too, but they're going to be off in the ocean where we hardly know anything about them because they are way out there and, off the coast of Peru in the ocean. And I want you to remember about them that we don't know that much about red-necked Phalaropes, and we don't know how long they stop at the lakes. We don't really know how many there are or what their trends are or where they go really. So I just kind of said that, but yeah, we think there's 2 or 3 million, again, really rough estimates. And if we knew how long they stayed at the staging lakes, we would have a better understanding of what their numbers are like, but we don't know if they stay for like a week or if they stay for like a month, and that can really affect our interpretation of the numbers. So when I started up this work at Mono Lake, these were the sort of questions that we identified, me and my collaborators. We wanted to figure out more about the population trends and the variability in that, see if climate change had noticeably affected their timing of when they come to the lakes, see how they were responding to the changing lake levels at Mono Lake because of their habitat use, and also see as things are changing, or how are they reacting, if when Lake Aber dries up, how are they reacting to that kind of thing, which I didn't realize was going to happen at the time, but it's been interesting. So a few of the challenges about working at Mono Lake and surveying it, it's really big, 8 by 12 miles thereabouts. So you gotta have some strategy. And I'm pointing out South Tufa County Park, which are really popular, easy to access places, but this whole eastern part of the lake is really hard to access and not usually surveyed. You got to get out there on a boat or a plane, and the shoreline itself is not very accessible. So if you want to know if there's Phalaropes in Mono Lake, you got to look out there too. And so we use the boat, and we do boat point counts, and we also do land-based point counts. I'm just going to kind of skim through this quickly, but we do them every 2 weeks to try to catch the peaks, the ups and downs of the populations of the 2 species. And we count in a circle from the boat at a regular distance with 2 surveyors looking to try to figure out what the error estimates are. And I was basing this on a protocol that my collaborator did in the 90s, but the lake was 8 vertical feet lower in the 90s than when we started this back up in 2019. So we had to modify our survey a fair amount by adding more points and stuff to areas that were newly wet, which was good news all in all. So I'm just going to spend a little more time impressing on you the challenges of counting Phalaropes before we get into the results and stuff. So you might envision like, oh yeah, Ryan's out there looking at, Sarah in this case is looking at this 1 Phalarope. Yeah, cool, 1 Phalarope, check, done. And it's at some points that's it. You're like 1 Phalarope, cool. But it gets a little harder as you get more birds. So here's another challenge for you. Try to count the number of Phalaropes in this picture I'm showing. And if you're advanced, you can think about which species you're seeing. So go. All right, so I'm going to give you the answer now. 15 red-necked Phalaropes. hopefully you had success with that. So maybe you're feeling confident and you're like, yeah, I can count 15 phalaropes. Check. This isn't so hard. So let's go back to this image that we've looked at a couple times. And here's another challenge. Try to count this photo. How many phalaropes do you see in this photo? Because this is what we end up having to do in real life. So take a second, maybe try to count by tens, or really 100s is probably the most feasible here. If you want to write in the chat what you think, then feel free.
500, 1300, 600.
Cool. All right. Well, so that gives us, when you have two observers, sometimes you get 500 and 1300 in the same count, and then you're like, yeah, we're figuring out our error. So I used a cheating technique by dotting this photo with a program, and I got 981. But I just want to impress that, our numbers are not 100% precise in this, and we're getting a good order of magnitude, but that 981 might be 983 or 985, Okay, so I'm going to move on to some results of what we're doing here, starting with Mono Lake and quickly expanding out. And to help you follow along, I'm going to have the little picture of the species with the name. So one of the cool things we can get out of this is looking at spatial use of Mono Lake with the phalaropes. And this is just one example. This is the surveys from 2020, and this is looking at red-necked phalaropes. And where those big blue dots are is where the birds are, and they're out there in the northeast part of the lake, which is that big part of the lake that I said is hard to get to. So one of the things that back in 2019, 2020 was, one of our questions was, are there still phalaropes in Mono Lake? We hadn't seen them for a while, and people were starting to get worried that maybe they had really crashed. We found that, yeah, they're out there, and they're just using, the lake level had dropped, and the habitat was such that they really are liking this area out in the Northeast Lake, which they have always liked, but they're really concentrating out there and not in the easily to see parts. So that was pretty interesting. And then as the lake has dropped more lately, they've moved over to the west, and they're getting to be easier to see in recent years. So point being that they really like to eat flies, and this is a red-necked phalarope in heaven amongst all the flies that there are to eat. And I think that the habitat, they're basically going wherever there's a lot of flies, and the flies are relying on the tufa rocks that are submerged for habitat, and that's what's driving different changes in their distribution. So another piece that we were doing was looking at the numbers and looking at the peak numbers. And just for context, back in the 80s, there was regularly like 50,000 phalaropes at Mono Lake, 50,000 Wilsons, which is what we're looking at here. The 90s, it was like 30,000. And so we're doing a different survey than what they did back then. For the most part, we have a few comparison points, but this is only about 20% of the lake that we're surveying, and we compare it to itself. So anyway, we got about 2,500 the first year. We got about 2,500 the second year. And then the scale has changed on this graph. And then we got 45,000 the third year. And then the fourth year, we got about 12,000 as our peak. So just the point being that these are surveys that are comparable to each other, and we can have a range from like 3,000 as our peak to 45,000. And so that tells us we need to look at the big picture at the other lakes, because they could be moving around a lot. This is the same thing for red-necked phalaropes, and the peaks are a little bit less all over the place, peaking at like 8,000 to 12,000 birds. But like I said, we don't really understand how long red-necked phalaropes stay around. So the Wilsons tend to build to a very distinct peak and then all kind of leave once they're fat and ready to go, whereas the rednecks, they might be around for weeks or months, and we're not totally sure. We're hoping to find out more about that from tagging. So like I said, we need to look at the big picture to understand what's going on here. Though looking at the small picture is great, but so we looked at, we're doing surveys at all 6 of these sites, and this is where SFBBO and San Francisco Bay comes in. These are all sites that that in the past have had very large numbers of phalaropes. And actually San Francisco Bay has had 40,000 in one of the historic surveys, phalaropes. So it can have a lot of birds. So the goal was to time our surveys throughout the summer and time them so that each place is doing their surveys in the same week, so that we can look at that week and say, okay, they probably didn't move around too much in that week, we hope. And I would be remiss if I didn't give credit to all these folks. There's a lot of, everybody's doing it at their own site and making this happen, and it's happened for 4 years. We'll do it next year too, and it's been great that everybody's been able to make this happen successfully. So now we're going to look at all the sites together, and orient you to this, that on the left, it has the colors of each site. This is looking at 1 year from 2020, again, just as an example. And then the magnitude of the dots is kind of showing how big the dots are compared to the other, how big the count is compared to the other sites. And the point being that Great Salt Lake is that blue dot, and it is dwarfing the other sites. So, you know, we can look all we want at Mono Lake's trends and try to untangle them, but we really need to know what's going on at Great Salt Lake to understand what's going on. All the other sites combined in this year did not really, you know, compete with Great Salt Lake's numbers. Red-necked Phalaropes, same thing. Also 2020, and again, Great Salt Lake is dwarfing the other sites. Mono Lake's making a little bit stronger showing, and San Francisco Bay actually in that year, but still there's more than double the number of Phalaropes at Great Salt Lake than the other sites combined. Okay, there's a lot of graphs in this section, but bear with me. So this is looking at it, so now we're looking at all the 4 years and our totals from those years at each site, which is probably one of the more useful ways to look at this. And again, the blue line is showing Great Salt Lake has way more Phalaropes than everybody else. There's a little bit of a decline looking like in Great Salt Lake, but like I said, there's lots of variability. So that's interesting point I've been making. Great Salt Lake's really important. I'm going to delete Great Salt Lake out of this graph, and then we change the scale, and now we're just looking at these smaller sites. And what I want to point out here is that Lake Abert is the brown line there, and you can see that the numbers have crashed basically since it dried up in 2021, 2022. There's a little bit of water in it, but there's not very much, and it's only supporting a few thousand Phalaropes. But those arrows I'm pointing out show there was that year where we got all those Wilsons at Mono Lake in 2021. Everybody was happy and celebrating, and then, but it might have just been because they all left Lake Abert that didn't have any water in it. So 2022 has some interesting suggestions that like Lake Chaplin in Canada and Mono Lake had bigger numbers and Lake Abert did not. It's a little bit speculative, but it's kind of the best we got in terms of understanding. And the signal from Lake Abert's pretty clear that the numbers have dropped because it's dry. So just to break up the graphs, here's a picture of what it looked like in 2021 when we had all those Phalaropes. They all really nicely cooperated and came to South Tufa, which is the most easy to see spot at Mono Lake, and everybody got to see them. Okay, so here's a few more graphs for you. So this is looking at historic data and contemporary data for Wilson's Phalaropes. And big caveat that the historic data, some of the methods were different. And like I said, there's a lot of squishy error in counting the magnitudes of hundreds of thousands of Phalaropes. But point being, we can look at this and see that there's an immense amount of variability, and you can have things go up and down. So we can't make too much out of the last few years, and we need to build a nice series of more years to really understand what's going on. But you can see like Lake Abert has the lowest, really low numbers right now, and that Mono Lake, you know, always has fewer birds than Great Salt Lake. And then last graph here is showing, this is the combined totals from all the sites. So this is sort of like the really important story of like what, when you add up all these from the high count from a single week from each of these years, what is the trend doing? And we just saw that there's a lot of variability up and down over the years. So we can't make too much out of these 4 years exactly, but that doesn't look that good. They're both sort of declining right now. And this 1986 dot I have is the only really comparable historic year we have, where there was almost 500,000 birds, and now in 2022 we only had 200,000 birds at the same sites. So, figuring out exactly what's going on with the trend is the challenge that we are trying to accomplish, and it's going to take more years of dedicated work. And happily, we have not seen this just like fall off a cliff. And I think that if we did see that, we could see that from this data, and we're not seeing it, and that's really good news that the birds are still around. Here's a little summary of that results section. So counting phalaropes is hard, as we all just learned. There's still a lot of phalaropes out there. They seem to be doing okay for now. They might be declining, but it's not 100% certain. We've seen some shifts around because of drying habitat probably, and we know that Great Salt Lake is crucial, and our recent data has underscored that. And the biggest development in the last 4 years that I did not anticipate was that suddenly we're in a situation where, of the 3 biggest sites in the Great Basin that these birds rely on, 2 of them are existentially in danger right now. Lake Abert dried up, and Great Salt Lake, I'm going to tell you about the situation in the next section. So here's a picture of hundreds of thousands of Wilson's phalarope, or maybe not Wilson's, either kind of phalarope at Great Salt Lake, just peppering the lake. And you can imagine if they do aerial flights at Great Salt Lake, and yeah, the margins of error for the counts that's really hard. How is that 500,000 or is that 300,000? Yeah, that we got to keep that in mind. But so Great Salt Lake, you've probably heard about this in the news lately. It's been getting attention finally. The lowest lake level on record in 2021 and in 2022. The volume shrunk by 50%, and it's on the verge of being so salty that even our salt-adapted invertebrates can't reproduce and grow in that salt anymore. So yeah, that is sobering. This is a little bit of a busy graph, but it's showing the Great Salt Lake elevation over the years, and they actually have this amazing time series going to the 1850s at Great Salt Lake, and it has fallen really low in the 1960s before, and it recovered in the 80s. But now in the 2020s, it doesn't look good because we're in the midst of climate change and very long-term drought, and there's a lot of people using the water in Utah that the lake needs. And it's hit its lowest point ever in this history. And aside from just being really salty as it gets lower, there's less water, so the salt's more concentrated. Another big issue is that they have these rocks that, if you've been to Mono Lake, we have tufa rocks that are weird rocks in the lake, and at Great Salt Lake, they have weird rocks called microbialites. And they're basically living mats of bacteria that form rocks. So they're kind of analogous to the tufa, but they are made of bacteria that's calcifying things. And same function where the flies are swimming down and they're laying their eggs on the rocks, and that's providing food for the birds. So these rocks are really important. Here's one of these horrible images of the lake drying up, where we have our microbialites underwater. Happy has all the brine fly pupa on it, and then now we have their microbialites exposed. And there's no brine fly pupa on it. And I actually recently learned that when the microbialites when it gets too salty, the microbialites die too. They can't withstand the salt. So if the lake comes back up and covers this back up, then they can recover. But this is I think this picture on the right is contemporary of what it looks like today. So that just means less food. Among other bad things for the microbialites, it means less food for the phalaropes, and that is bad news. And most of the microbialites in the lake will be exposed as the lake continues to drop. They're kind of at the level that's being exposed right now. So I know I keep on hammering this point home, but Great Salt Lake is Wilson's phalaropes, basically. Like, they go hand in hand. I'm very concerned that if we lose Great Salt Lake, then Wilson's phalaropes are in big trouble. 60% of the population can be there at once. And I've been, telling the story of phalaropes for a few years now, and I have become concerned that we still are considering phalaropes least conservation concern in terms of our International Union for the Conservation of Nature status, our Endangered Species Act status. They have a big population that we don't understand very well, but they're set to lose 60% of their habitat in a very short period of time if we don't do something for Great Salt Lake. So Lake Abert, also a sad story, but so this is what it looks like when it's full. Here it is. In April 2021, it had some water in it, and then by June it had dried up and it's still dry. So this is also a water diversion in that watershed for mainly for irrigation of alfalfa and other crops. And just lots of different people taking the water out, and lots of different water owners, and hard to get that water back in there. Though what's really being talked about to save these places is buying the water rights for the lakes, and there's some progress on that. So moving from that sort of grim situation, I just want to highlight San Francisco Bay, because this is an SFBBO talk. So what's happened there is that you know, in the South Bay, there are all these hypersaline ponds that were for salt evaporation in the past, and they're kind of outdated now and being restored to lovely salt marsh for all the species that depend on salt marsh. And in that left picture, you can see all those kind of funny colored ponds as places that were so saline that they had shrimp and flies and things for phalaropes. So it's all been good to restore this for the salt marsh, but and that's been helping species like the Ridgway rail that really rely on the salt marsh. A lot of species do, but the unfortunate side effect is that the phalarope habitat is less prime than it used to be in the South Bay. And so this graph is showing SFBBO data of, you know, big counts in the tens of thousands, multi-thousands back in before the salt ponds were restored. And then now we rarely are exceeding 1,000 phalaropes in the zones that SFBBO is counting. So that is what it is. And you know, probably we've thought about our values for the South Bay and picked that. And but it's good to know that that's happening, and to keep those kind of things in mind as other habitats are evaluated and decided about how we're going to treat them. And I'll make an aside that SFBBO uses volunteers to monitor phalaropes in the South Bay. And if you are a Bay Area person and want to get involved in that, I hear that they could use help. Okay, so now we're gonna take a deep breath and move on from North America for a second. And we're going to go down to South America, where the phalaropes go covert with the flamingos in the Andes. So this could be Mono Lake. You could trick me maybe, but this is actually Laguna Chaxa in the Salar de Atacama in Chile. And this is one of the spots the phalaropes go. And they actually have a fun relationship with Chilean flamingos. Chilean flamingos do this like pitter patter dance that they use to get the invertebrates to come up, and then the Wilson's phalaropes, they'll hang out around them, and they actually increase the amount of food that they can get by hanging out with the Chilean flamingos. So that's pretty cool. And down in this South American zone, it's kind of awesomely similar and different in various ways. So they have, you know, these species that are so similar to ours, like the Andean avocet and the Puna plover that looks like a snowy plover, and the silvery grebe that basically is an eared grebe. And then they have 3 species of flamingos and the diademid sandpiper plover, which is like nothing else I've ever seen. So, you know, it's super similar and also super different, and it's pretty fun. And one fun thing that I got to be involved in, and that has been a big advancement for phalaropes, is that there was a 2020 survey that was led by the Western Hemisphere Shorebird Reserve Network that surveyed the entirety, or tried to survey the entirety of Wilson's phalarope non-breeding habitat in South America. And this is an entire continent. So it's a really hard thing to do. 753 sites were monitored, and these were not easy to access sites. They're way out there in the Andes and things. And the takeaway from it was that we actually think we have about 1 million Wilson's phalaropes in the world. and not that 1.5 million number that I said before. Does that mean that 500,000 went away? I'm not sure. Again, like comparing to the historic data can be really hard. They use different methods. That was from North America, but we think 1 million is a reasonable estimate for them. Just to underscore, no small undertaking. There's a lot of really hard sites to get to. They used hundreds of volunteers to make this happen. Lots of trucks stuck in the mud, for example, in Patagonia. And I just want to show you a couple of the sites that we went to. I got to go out into the middle of the Andes into the most remote places I've ever been. One of the places was Salar de Surire in Chile, which had 14,000 Phalaropes, and it's at 14,000 feet. This was the site with the most Phalaropes we had in Chile. Oikonos was organizing the Chile part of this, I forgot to mention. So our little team was tasked with surveying an entire country in the Andes, which was a big challenge. Just another sort of example of the spots that these birds are going. So Laguna Colorada in Bolivia. There's the flamingos. Yeah, way up there in the Andes, just really cool sites. So we identified a lot of important sites for them, and I'm going to talk about the most important site for them in South America, which is called Laguna Mar Chiquita, also called Anzanusa, sometimes in Argentina. And this site had 500,000 Phalaropes in 2020. So it's basically the Great Salt Lake of South America. And this picture is of flamingos, but it's the best I got. So Laguna Mar Chiquita, where is it? It's in Argentina and sort of the lowlands, kind of analogous to Great Salt Lake. It's in the valley below the Andes, and it's gigantic. 1,750 square miles as opposed to 117 for Mono Lake. Here I superimposed 14 Mono Lakes on top of it. For scale, it's really big. So if you've been to Mono Lake, you know Mono Lake's big, and Laguna Mar Chiquita is really, really big. So it's the biggest South American saline lake. It has the most Phalaropes. It's got lots of flamingos and other species at it. And the threats are similar to other places. Happily, I don't have to report that it's drying up too. It's not drying up at the moment, but it has other issues like lots of agriculture around it and water pollution going into it. And interestingly, industrialized tourism, unregulated tourism. Here's a picture of the folks hanging out at Laguna Mar Chiquita. It's a really popular domestic tourism spot. So that's great because people care about it, and it's also just, you know, there's not a lot of oversight. People are just driving ATVs and motorized paragliders and kind of things that might not be good for wildlife, and could use some more regulations, really. And the good news on that front is Laguna Mar Chiquita was designated as an Argentinian national park in 2020, or in 2022. And this was a long time coming. It was a major political process in Argentina that required the Senate and the Congress to vote on it and purchasing the land and things. Folks in Argentina are really excited about it, and it's going to provide protection for the lake. I've been assured it's more than just a paper park, and it really will provide protection for the water of the lake, and, you know, help with those tourism issues, and just bringing attention to valuing this place. So that's some fantastic news that we can report. Part of the reason that I know about what's going on in South America is that we hosted a International Phalarope Working Group first meeting in 2019 in Mono Lake, where we brought folks from 5 countries up to Mono Lake and had a great gathering where we sort of all put our heads together about Phalaropes. This was before the pandemic, when things like that were still easy to do. And that really just got the ball rolling from the get-go with having this be a very internationally minded, big picture minded effort. And it's been really cool to have these international interchanges. Marcela Castellino from Mar Chiquita is a researcher who grew up down there, similar to me at Mono Lake, and she came up and spent a week with us at Mono Lake this summer, and she's working on Phalaropes too. Myself and a bunch of Mono Lake people are going down to Mar Chiquita in a few weeks to go celebrate the new national park and learn about Mar Chiquita. So I think those interchanges are really, really important because they help us think big picture and learn lessons from each other's places and learn how to do things effectively. All right, so to bring this talk home, I'm going to talk some musings about the future of phalaropes and where we're going with this. And I'm going to pose this question, are phalaropes the polar bears of saline lakes? And I'm going to answer it and say, yes, I do think so. You know, polar bears are famous for being threatened by climate change. They're losing their Arctic sea ice habitat. And phalaropes are being threatened by climate change too, and they're losing their saline lakes habitats. And neither of these species can survive without those habitats that they rely on, that climate change is changing in real time. So I think that phalaropes, there's a good case that they are just as much the poster child of climate change as polar bears. Because climate change is impacting the saline lakes right now. And it really, really is a major stressor on the lakes. And I'm emphasizing that it is, but another important point is that the diversion of water from these lakes is what has caused it to be such a crisis. If we were not diverting water from Great Salt Lake and Lake Abert and Mono Lake, then the lakes would be withstanding this a lot better. If we were still diverting all the water from Mono Lake, then Mono Lake would be gone at this point because of climate change. And instead, it's just sort of in a unfortunate limbo of not coming up to the where it needs to be, but not dying either. So this is actually good news because it makes the problem more solvable. As we've seen from Mono Lake, there are solutions that can be struck to make the water go farther and be shared. And it's not just like, oh, climate change is destined to destroy all these lakes. If we can solve these more solvable problems, then climate change will impact them, but it won't necessarily destroy them. So the solutions that I see are conserving saline lakes locally, which is a big tangle of water rights and things, and that's going to have to happen locally, but also thinking about it big picture and getting, you know, powerful players to think about it big picture, governments and funders and things like that. And I think the story of phalaropes can be helpful to accomplish this. I hope that it doesn't start to gain a lot of attention when the phalarope numbers that I showed you drop off a cliff. But if they do, then that will be a powerful thing to show people to lobby for saline lake protection. As I mentioned, Mono Lake shows that it's possible to share water with the environment and human uses. And, you know, it's always imperfect solutions, but Mono Lake is a really nice story to look at to show that, yeah, this can be done. Owens Lake that I mentioned and showed the dust storm earlier as like the most horrible crisis that could be, proves that habitat can be restored because they've dealt with this by putting lots of water back on the lake to control the dust storms. And now there's thousands of phalaropes at Owens Lake, and it's not providing as much habitat as it used to, but it is definitely providing habitat. And these systems are really resilient. Thankfully, brine shrimp and alkali flies can come back when you put the water back. Maybe not after hundreds of years, but they can last for a long time in the cyst form and everything before they go away entirely. So just to reiterate the hopeful developments, Laguna Mar Chiquita is protected. At Great Salt Lake, they're really getting into gear for, it's a little bit late in the game, but they're really starting to pay serious attention to it. It didn't used to be that if you let water go into Great Salt Lake, that was considered a wasteful use in Utah, and now they've changed that to legally to be a beneficial use to put water in the lake, which is great. There's millions of dollars of funding for USGS to research saline lakes that's very likely to pass in the next year, which will help us with things like water budgets and understanding what the lakes actually need to survive. There's also a water banking funding going on in Great Salt Lake to buy water for the lake. Lake Abert's still pretty challenging, but there's a new collaborative process to get everybody together to figure out how to get water to the lake, and that'll probably involve buying water rights again. So those are some of the hopeful things. I mentioned a few others before, and one of the main things is that, yeah, you can restore these places if you just put water back on them. So what we'll be continuing to do in the future is the surveys as the habitat changes. I think it's more important than ever to be watching what's happening, continuing to do surveys in South America and learn more about the habitat there. We are starting up a phalarope tracking program in 2023 to understand how long do they stay at the lakes and how do they move between them. And then there's also a big survey underway to twice annually survey the entire Intermountain West, all the shorebirds in it at all the sites, which is a really big undertaking that we're helping out at Mono Lake. So I'll just end it here on the idea that we need to, it's a cliche, but you need to act locally and think globally. And yeah, we need to worry about Mono Lake on the local level and all these other places, and then we need to think in a hemisphere or worldwide level about what's going on with other places, because having just one of these places isn't going to save the phalaropes. We got to have a whole network of them that they can rely on. So I'll just wrap it up here with the credits. Thank you to all the volunteers and staff. I did not do this on my own. There's been lots of people that have helped with the surveys just at Mono Lake. These are folks that volunteered on the all shorebird survey this year, and the pictures. Lots of funders and partners to thank at Mono Lake. And I want to emphasize thank you to those of you that have made private donations to this project. We are a small nonprofit, and it's very, very helpful. For coordinated North America surveys, thanks to San Francisco Bay Bird Observatory for doing the work in San Francisco Bay and all the other partners that work at the other sites. And I will leave it there and say thank you. And that, yeah, if you want to support the project, oikonos.org/donate, we could definitely use it. I emphasize we're a small nonprofit. And if you want to get involved as a volunteer or just learn more, then you can email me at my contact there too. And thank you.
Awesome. Thank you so much, Ryan. That was great. I thought it was a great talk, and it's really cool to hear about this big picture look at how the phalaropes are doing on a larger scale. So thank you so much. I really, really do appreciate that and all the work that you're doing to help them.
Yeah, thank you.
I'll read out some questions to you that I saw in the chat here. So, before that, I do want to mention that a couple of people had some good comments that I want to share here, that the brine flies are not just tasty for the wildlife, but also people at Mono Lake collected the fly larvae before and dried them for food. And Nora also said that we are still fighting for Mono Lake's future. So thank you both for sharing that. So as far as questions, Linda asked, do the phalaropes stop at Salton Sea?
Yeah, Salton Sea is an important place too, and it's been tough to get surveys going there. It's a really big place, and one of the reasons that we had the surveys at the places we did is because people could do it there. So they're working on Salton Sea for this new survey that's doing all the species, and probably there's phalaropes going there. It's interesting because Salton Sea is sort of on a cusp where it's gotten too salty for the fish, but it's not yet a hypersaline lake that has the shrimp and the flies in it. So there's various solutions being floated, and some of them involve like breaking the lake into two parts and one part of it being hypersaline and one part not. It actually could be potentially, as it gets hypersaline, it could become better habitat for phalaropes if it starts to have shrimp and flies. But yeah, it's a tricky policy situation.
Yeah, interesting situation there. Another question from Linda was, can you use drones to survey for phalaropes?
Yeah, the short answer is yes, you can use drones. Or I think we can use drones. I'm working on getting drone donations and learning how to use drones and getting a pilot's license and figuring out all the technical aspects of doing drone counts for phalaropes. And of course, it has its whole host of complications, but I do think that that's something we're moving toward in the future, and that it can be used for photo validation of our counts where we can dot those photos, or we can do, focus counts of phalaropes and really high density areas and things like that. So yeah, we are moving toward doing that.
All right, yeah, another plug for supporting Oikonos so you can do that work. And then Or asked, why do populations peak at different times of the year in different years?
Oh, that's a really good question. That I don't think that we have a definitive answer to that. And that's something that I think is interesting from our data that I'd like to learn more about. But yeah, some years, like that year when we had all those phalaropes recently at Mono Lake, we had the 45,000 count. They showed up really early. And my best speculation is that like it was a dry year, and on the breeding grounds, it might have been so dry that they failed, and then they're gonna start migrating to the staging sites earlier if they fail breeding. So that another also, like when we see a lot of phalaropes early, it might not be a good sign. But it's really hard to say. I think that the tracking work that we are moving toward might help us understand that some, to see like when birds leave the breeding grounds and things like that. But yeah, hard to unravel that.
Yeah, really interesting. And then our next question is from Terrence. Can you tell us a little bit about the different plumages? So they noticed that some of the photos of the red-necked phalaropes looked very different, such as the one that you're showing here.
We're looking at the breeding plumages of the phalaropes in this image, and these are actually the females. I didn't really hit on this, but they have a cool reversed sexual roles in phalaropes, where the females are more colorful. Usually in birds, the males are more colorful. The females are more colorful. They are attracting the males, and then they're mating with them, and then they're taking off and not taking care of the eggs and chicks, which is pretty weird for birds. So these are the female actually individuals of these species, and yeah, the bright colors. And then let me see if I can find. So this guy here is a male, probably, with the drabber red on the neck, but maybe also in breeding plumage. And then, for example, these guys are in non-breeding plumage for the red-necked phalarope, and the non-breeding plumage of the Wilson's phalarope looks similar, of very much just black and white. So when they come to Mono Lake, they are in their breeding plumage for the most part, and then those feathers that they're molting are molting into their non-breeding plumage. And when we see them in South America, they're just black and white, and they don't have the red.
All right, thank you for that. And then Terrence also asked, do the phalaropes only come at certain times of year here probably in California, right? Terrence said, I would love to see both kinds, but would be traveling from Louisiana. So want to make sure I come when they're there.
Yeah, really good question. They're actually here for a pretty short amount of time when the big numbers are here. So catching the Wilson's phalarope especially can be challenging. But late July to early August is your best bet. If you're at the Saline Lakes, is probably the best place to see the Wilsons. The rednecks are a little easier to see on the coast, in the Bay Area. South Bay is a good place to see them, and they'll be around like August and September. They'll be around in bigger numbers.
Yeah, so come visit us then.
Yeah.
So the next question from Orr, and you've already touched on this a bit, is when saline lakes dry and then fill up with water again, do the invertebrates return? So it sounds like the answer is yes, as long as it's not dry for too long. Is that right?
Yeah, I'm not an expert on this, but I do know that like for instance, Lake Ebert dried up, and then it was dry for a few years, and then it got water back in it, and it had brine shrimp and flies in it again. And brine shrimp especially are known for, there's other species of fairy shrimp, as they're called, that like live in the desert in these little water pockets, and when it rains, they wait decades, and then when it rains, the little cysts hatch out, and suddenly there's this little 2 by 2 foot pool in the desert full of brine shrimp. So they're incredible species that can last really long in these dry, desiccated environments. And Owens Lake is a good example where they put water back on the lake, and there are brine shrimp and flies back in Owens Lake. So I don't have a hard data on like how long can a shrimp egg last before they're not going to come back, but I think it's pretty good news that they're pretty hardy.
Yeah, that is encouraging. And then Terrence asked, do the phalaropes use the spinning feeding technique on the saline lakes?
Yeah, I didn't talk about that. But another really fun thing phalaropes do is they'll spin in a little circle, around themselves and make a little vortex that brings the invertebrates up to the surface, and they definitely do that on the saline lakes. You see them doing that all the time to get the fly. Probably the fly larva is what we think that they really like to eat. So it's suspended in the water column and it brings it up.
Nice. I will look for a video to send to everybody. All right, so let's see. Rosie asked, what sites are Wilson's phalaropes using in the Great Plains?
Good question. One of the big sites for them is called Cheyenne Bottoms in Kansas. And interestingly, the phalaropes are going, let me pull up another picture of this, but they're going on their migration through the Great Plains more on the way back north. So in this image, you got this swath in the Great Plains where in that yellow is migration, or maybe that yellow, I think that yellow is the northbound migration. So they tend to come and hit the saline lakes on the way south on the southbound migration, but on the northbound, they kind of go straight back up through the Great Plains to the breeding sites. And Cheyenne Bottoms is probably the biggest one that I know about out there. But they will go to, they concentrate at these big salt lakes, but they'll go to any small wetlands on the way too. And one thing I looked at as I was researching or getting this talk ready is eBird trends from this whole range. And it was interesting to see that mostly like across the smaller sites, there's more negative trends, across the entire swath of the habitat, where probably these small, as we have droughts, the like smaller sites dry up faster and become less usable. So then we get the birds concentrating at the bigger sites. And I think the Great Plains has more kind of those kind of smaller sites, though I'm not as familiar with all of the sites there.
Very interesting. And then Rosie also asked, is anything known about migratory connectivity between specific breeding sites and specific saline lakes?
No, we don't know anything about that. So that's one of the questions that we want to address. We're going to try to start tagging next year. And the idea is to catch birds at Mono Lake, but also in Saskatchewan where they breed. And we're going to work with Environment Canada, and it'd be really interesting to either put tags on birds and the breeding sites and then see, which birds are going to which lakes. We don't know if there's like fidelity, like they like to come to the same lake every year, or like certain breeding areas go to certain lakes. That would be really useful to know. Another way I'm interested in doing to learn about that is using genetics. Some species you can like find genetic markers that go with the region or the breeding colony, and try to, see if you can see those markers at different lakes. It's a little bit of a challenging thing to do, but I think tagging is the most imminent way to figure it out.
And is the plan for that the MODIS tags?
Yeah, we're trying to use MODIS tags, which is this technology that, these birds are really small. I didn't talk about this either, but they weigh as much as a golf ball when they arrive in Mono Lake, and then they double their body weight to 2 golf balls, and then they fly and it goes back down to 1 golf ball. So they're really, really little. So you can't put a big honking tag on these birds, and you need to put a little micro tag on the bird if you're going to tag it. And so there's this system of external receivers that has been developed and used often with songbirds that are also small, where the bird's flying around, and when it passes a receiver, it picks it up. So the trick is to get a network of receivers at all the different places that are relevant. And again, like saline lakes were not prioritized early on in that system, but they're finally getting a lot of these receivers installed. So the Mono Lake Committee is working on putting them at Mono Lake. SFBBO is putting them in the South Bay. Great Salt Lake's getting them. We're working on trying to get some sites in South America, like Laguna Mar Chiquita, to have them. So someday, hopefully soon, we'll be able to say, yeah, this bird started in Saskatchewan and went to the South Bay, and then it went to Laguna Mar Chiquita, but we're not quite there yet.
Well, that is definitely very exciting, and I hope that we will get to hear about that in the near future.
I'll give a talk when that happens.
Yes, we'll look forward to that. All right, well, I think that is the last question that I am seeing in the chat. So first of all, I want to thank you, Ryan, for this wonderful talk. And I also want to thank everybody for attending and sticking around. Ryan, is there anything else you would like to share with the audience before we sign off?
Just thank you for coming, and thanks for listening.